Hello everyone, welcome to our channel. So this series we are going to solve one more question asked in the GATE exam. So all right. So the question related to our the question they given actually output response of system is denoted by yt and its Laplace domain is given by s equal to 10 by s into s square plus s plus 100 under root 2, and they are asking that find out the steady state value of yt. Steady state value, if you say steady state value, yeah, final value, final value. All right. So if they asking the steady state value, yeah, final value, this will be same. Okay. So for this, how to solve this question? So we need to apply the final value theorem for the solve the question. So for this, useful data is required. They given here. The final value theorem for a given signal is defined by limit t tends to infinity yt is equal to limit s tends to infinity s by s, and so this is in time domain. All right, and this is in Laplace domain, s domain. Generally, this is frequency domain. Okay, so here, uh, yeah, we can say complex domain because here is a real part and imaginary part also involved. Okay, so simply we can say S domain and this is a time domain. All right. So here, what is the mean of higher value theorem? It means given signal, Laplace domain is given without converting to the again time domain. Straight away we can find out the final value theorem, final value of the system using the final value theorem. All right. So how to apply it? This for this is a very simple question, like simple, just straight away, just yes tends to 0. Yes, what is the value? Yeah, by s they given 10 by, here you can simply you can write it as tends to 0 and s by s. So limit s tends to 0, s 10 by s s square s plus 100 root 2, s cancel out, then you apply the put the s value. So 10 by s square s 0 gone, then 10 by 10 10 cancel out, look at the 1 by 10 root 2. All right, so option is correct. But in case of final value theorem, before to apply final value theorem, or we can say final value theorem is not applicable for each transfer function. Okay, so like now we have to explain more in final value theorem, like for example, if system behaving like that, uh, behave like that, so this like if you take e the power minus system is like in I'm writing in s domain, system like s plus, like for example s plus 3. Okay, and ROC is right hand plane, so 1 by s plus 3, so real part greater than minus 3. So here, what is the Laplace inverse for this in time domain? And e the power minus 3t ut. So we get like that. So this if t tends to infinity, t approach to infinity, then response will be, this output final value will be 0. All right, and like if system like as we know second order system, under the system. So this will be like final value theorem. If you apply it here, so we'll get t tends to infinity at time dies out, then what is the final value? It is 1. Okay, I just writing final value, or we can say distribution value. And like if your function is behaving like that, so it means here final value is be not cannot be defined because system get oscillatory. So here final value not exist. And one more thing, like one more thing let we will discuss, like if system behave like that, it means our pole will be in a right hand plane 1 by s minus 2, so it will be diverse. So here final value will be infinity because uh, final value will be infinity if you see the curve, because you're not going to diverge. But if you apply here a final value theorem, so what will get? Limit s to 0, s into 1 by s minus 2. So we'll get the value is minus 1 by 2 is equal to minus 0.5. So this is wrong actually. So this is wrong. So in case of final value theorem, first we should know is only applicable for the stable system. So like if you classify in S plane, like this my S left and right hand plane. Okay, this is complete S plane, and this my left hand plane. So in this, and one more thing here we can also classify. So let me change the color. So this my j omega axis, imaginary axis. All right. So I'm just excluding here origin. Okay. So this imaginary axis. So it means like as we shown here, this one oscillatory function. It means pole will be lie in the imaginary axis. Means it will be conjugate each other, like 1 by s square plus 4. So this will be in sine 2, yeah, we can say here 2. Okay, so sine 2t and ut. So here 2 is a omega t sine. So omega, this will be oscillate with the frequency of 2 radian per second. So like this will be exist here like that, plus j minus 2j. All right. So we can say like final value theorem only applicable for the left hand uh, stable system. We can say a pole will be lie in the left hand plane. And one more thing, here we are not talking about the origin. If you pole also lie in the origin, let me explain clearly. Like as we know, pole at origin is also is equal to the tells about the type of the system. Okay, and pole at origin it also is integrator, right? So like type 0 system, type 0 system means there is no pole at the origin. So like this is function s plus 1. So this is type 0 function, a type 0 system. So type 0 system, it means if you apply the final value theorem, then it will get always 0 value. Okay, so it means it's completely dies out. You can see here this will be in time domain e to the power t ut. All right, so here we can see here straight away we can see here t tends to infinity, you will get the final value 0. All right, and then if you go for type 1, then one pole should be in origin. Okay, so like if you any system, like we take this here type 1 system, if you find out the final value theorem, apply the final value theorem, then okay, so s cancel out, will get the 1 value. Okay, like if you is some function like 1 by s into s plus 2, then here 2 we will get the final value 0.5. All right, then and if you type is 2, type 2 means pole at origin will be 2, 1 by s square, then 1 by s square s plus 2. So limit s tends to 0, s into 1 by s square plus 2. All right, then you will get the infinite value. So here value will be infinite. So it means, and it means if your system type is 2 or more, then final value will be get, system get oscillatory, a system going to diverge, then final value going to infinity. So here we can conclude here only type 1 system final value or steady state value will be finite. We get some value. Okay, and type 0 system steady state value will be always 0. Okay, so like for example, they given question in GATE exam. Okay, so here we shown here, this is our type 1 system, so that's how we get the finite value. Okay, for example, this question, if you let me like if you write down like that, 10 by s square plus s plus 100 root 2. So this is type 0 system. So if you apply the Laplace transform, sorry, final value theorem, so here we get the 0 value. Okay, this is type 0 system. All right, and if you like if you s square, this is a type 2 system, then we get the final value will be infinite. All right, so this is a like role of pole at origin. Okay, so we can say like integrator, it means pole at origin. So type 1, okay, means I would say single pole gives the finite value, finite steady-state value. Okay, so that's a variation we can also observe in the GATE exam related to finite value theorem. So straight away we cannot apply the finite value theorem. First should be no system should be stable. It means all poles should be in left hand plane. Okay, if all pole left hand plane, and in case of pole at origin, and this is not a problem because if you pole, there is no pole, then we'll get the 0 find value. Okay, if one pole there, then we get the find value is finite value. And if pole more than like the repetitive pole at origin, then we get infinite infinite find value. This is all right. Okay, so in this our find value is applicable, but find value is will not applicable for the where we get the right hand plane. Okay, system unstable. Clearly show system unstable, that time is not we cannot apply the final value theorem, because as I already explained here, like 1 by s minus 2 system is unstable, but if you apply the final value theorem, so it shows the minus zero point 0.5. Okay, system is not stable at all, it's going diverge, but if you apply the final value theorem, it shows that the value is minus zero point 0.5, so this is not correct actually. Okay, so this thing should be understood here. Okay, so let me summarize here. Final value theorem is only applicable for the stable system. Okay, and final value before to apply the final value theorem, we should know like whether system is stable or unstable system. Okay, it only applicable for the stable system, because if you apply the final value theorem for unstable system, you will get the you will land up on the incorrect answer. This is not good actually. Okay, so here we have done all variation related to the final value theorem, and we also highlight the limitation of final value theorem. So like we also understood that final value theorem how fact on the type of the system, whether it is type 0, type 1 and type 2 and so on. So if a type 0, final value always 0, and type 1 final value will get some finite value. Okay, if type 2 or higher or higher value like type 2 or higher of the system, then final value always infinite. Okay, so like that we can understand the system, we can solve this problem. Okay, so I think that's all for this video. This is a very I am not able, video is not interested to go more long actually, because I'm only highlighting the concept which are generally frequently asked in gate exam. Okay, so hope you understood. Okay, if you any doubt related to final value theorem, please do comments, and definitely I will if any doubt I will make one more video about this. Anyhow, we are solving all questions asked in gate exam, so again final value question will come into picture. Again we will repeat the same concept, so we will get more ideas about this. Okay, so that's all for the this video. Okay, so thanks a lot.